Values are.
Yeah.
And I don't leave them there all year, so it's just something to glance at sometimes. You figured out what they are yet?
Not exactly. I remember us talking about this at one. I feel like something similar to this, where we set up the same thing and we had the ones in that spot. And I don't even remember. It was just a few days ago, but I swear we did something like that.
It's unit circle tangent values.
That's what it is.
The tangent values of unit circle. Even though you can find them out with sine divided by cosine, there's only a couple. So if you know the pattern around the circle, I don't know. I think it's worth memorizing, but you might disagree.
Alright guys, you will need assignment number 20, which was the big book assignment that we started last class. Part of what we'll do in the second half of class today is give you more time to work on that. So if you would, go ahead and get out assignment 20. Give me a second to update attendance and then I'll tell you what we're doing today. Johnny. All right. So first up, you should have picked up two handouts on your way in. One of them is the book handout. So of course, please don't write on that. I do want that one back, but I just feel like that's easier than giving you a book to use during class. It takes up less space. But the other handout you picked up is called a circuit, and I misnumbered that. So the very first thing you need to do is you need to change that from number 20 to 21. So the worksheet that you picked up on the way in that says something about a circuit, actually needs to be 21, and I had numbered it as 20 for you, but we already had it 20. So unfortunately, that's just going to happen sometimes when I try to number them for you. Okay, so what we're going to do today is we are actually going to practice some of the derivative stuff that we have talked about the last 2 classes. So in this unit, we have talked about what a derivative is, basically slope. We talked about a handful of derivatives you need to memorize, like the derivative of constant, the derivative of e dx, the derivative of sine and cosine. There's just some that have to be memorized. We talked about power rule, done a book assignment on it. And then last class, we talked about product and quotient rule and started a book assignment on it. So today what I want to do is to spend roughly the first half of class-ish going over the power rule again. Because if you can't do the power rule, then that makes the product and quotient rule more difficult. And so that is assignment 21, and I will give you some directions on how to approach that since this is our first circuit of the year. Then as you finish that, I'm going to ask that you turn it in to the box along with assignment 10. So assignment 10 was, of course, from weeks ago. It's just one that I didn't have time to collect, but I still want to give you points for. So when you finish assignment 21, just turn it in with assignment 10. And then roughly with the second half of class, I want to give you more time to chip away at the book assignment. So I'm asking for you to aim for about 10 book questions in class and about another 10 questions, another 5 questions for homework. So that book assignment still won't be finished by Thursday, but it should be getting pretty close after I give you this class time and ask you to do 5 more for homework. Okay, so a circuit is kind of like just a worksheet with a bunch of questions on it, but I think students last year probably thought this was one of their favorite type of assignments because it's not random questions. This one not so much, but generally circuits are very, very, very well thought out questions.
Teachers, once again, please pardon this interruption, but at this time we need underclassmen who need retakes, last name beginning with K and L to make their way to the lower part of the PAC at the stage area. So 9th, 10th, 11th graders, last name beginning with K or L. If you did not get a picture at Bulldog Blitz, please make your way to the PAC. Thank you.
So the questions aren't completely random. Typically they get a little bit harder as you move along. There is a way to kind of check your answers, and at the very end all of it kind of fits together like a puzzle. So here's how you're going to do this assignment. So I'll explain how the circuit works to you. And honestly, again, we're probably going to do like 10 or 15 different circuits throughout the year. So this is, I'm just kind of holding your hand here at the start since you may not know what the directions are. So in the top left is question number 1. You can see they've already numbered it for you. And this circuit is wanting you to find the derivative. So unfortunately, we're still in that part of the year where we're just got to be able to take the derivative so we can use it later on this semester. And there are a few questions on here that if you really insist on doing product or quotient rule, that's fine since you've seen product and quotient rule. But everything on this worksheet should be able to be just power rule. So we might have to split apart fractions, we might have to use exponent rules, but every one of these questions can be the power rule. So question 1, again, they start off a little bit easier, but bring the power down, lower the power by 1. Just do that as many times as you can. And then remember the derivative of a constant is 0. So there's the derivative. If there was something I could simplify, like maybe taking out a GCF or, I don't know, maybe get a common denominator or something, then I could potentially have to do that. But this answer tells you where question 2 is. So if my answer had been this, if my answer had been 7/6 x to the 1/5, that would mean this is question 2, and you should do it next. But it's not. 15x squared minus 8x plus 9 is right here. The one that has that answer to the previous question tells you where the next question is. So that should be your second one that you do. And apply the power rule a couple times there, and you're going to have that answer. And that answer tells you where question 3 should be, etc., etc., etc. Now, most of the time circuits don't have quite this many questions. I think this has like 24 total. But again, power rule can be very quick sometimes, so that's why there's a few more on there. But the other nice thing, well, one nice thing is, if I did question 1 wrong, I'm probably going to realize it's wrong because none of the answers are going to look like that. So that's my hint to double check my math and to double check that I couldn't simplify it more. The other nice thing is the very, very last question, the answer to the last question is supposed to loop back to this very first one. So if you don't get this for an answer on your last question, you know something's off. You must have missed at least 2 of the questions. But if everything matches up to one and the last question matches up to that, then everything kind of fits together. There's a feeling of completion, and it's basically a way to check your answers because you're not going to accidentally mix them up and still do that. So, so I did question 1 for you. I showed you where question 2 was. So go ahead and start with that, please. Go ahead and just start doing the first couple and see which one gives you problems, if any. Now, I know power rule in theory is pretty easy, especially if it's written like this question 1. It's not hard to use the power rule a couple times. But if it was always this easy, or you were all up to speed, ready to do all the question types you need to be able to do with the power rule, I wouldn't give you this. So there should be some learning and some growth from these practice questions. I don't think many of you or any of you will be able to do all of these without any help. But if we can't do power rule, then we can't do product quotient rule. And if we can't do those things, then we can't do the other thing called chain rule. But chain rule is for another day. Chain rule is pretty much the only thing in Unit 2 I haven't shown you yet. So, no new calculus today, just trying to get better at the calculus you've seen. Okay, does anybody need help with question 2? Okay, everybody worked it and found the answer somewhere on the worksheet then? Okay. Again, I'll offer lots of help on this, but I want to try to stay with where I think most people are at. So, some of you may fly through this, which is fine. If you're great at power rule already, then I don't want you to have to spend a long time on it. Yep, there are questions on the back, by the way. So if you think your answers, that you did something wrong because you don't see your answer, it could be on the back. Feel like that's kind of obvious, but somebody, second period today didn't see that. So. Yes.
Could you work number 4?
Number 4? Okay. The only problem is I don't have my answer key in front of me, so you have to tell me which one you think is number 4.
The one where the answer is 15x to the 4th plus 8x plus 1.
This one?
Yes.
Okay, you think this is number 4, you said?
Yes.
Okay, so all 3 of these are already set up, all 3 of the terms, first, second, and third term. These are all set up in the form for power rule already. You've got a number times x to some power, a number times x to some power, a number times x to some power. So we should be able to jump straight into the derivative. So do the power rule here, bring the power down, lower the power by 1, and again, bring the power down, lower the power by 1. And this one, I don't know why this one's always a little bit harder, but it's the same thing. It's still power rule. When you bring the 1 down, 3 times 1 is still 3. You lower the power by 1, x to the 0 becomes 1. Multiplying by 1 doesn't change anything. Well, none of the answers are going to look like this. So how much simplifying you need to do just depends on the question, depends on who made it, depends on what your multiple choice options are. But one thing I can promise you is that negative exponents are always going to be considered unsimplified. So bring this x to the negative 2 down to the denominator to make it x to the positive 2. Bring this x to the negative 3 down to the denominator and make it x to the positive 3. And then I would start looking for answers.
Yeah, it's the far bottom left one on that same
Okay.
page.
Yeah, so even before I started to check, I knew they were not going to leave negative exponents in their answer, so. You're welcome. Okay, anybody have questions over number 3? Again, I don't want to get too far ahead of where I think most people are. But anybody need to see question 3 worked out? Okay, I will check back in a few more minutes then. Now, of course, if you get one and you get stuck on it, don't give up instantly, but at the same time, don't spend 5 minutes on it stuck. Just work a random question, and then you'll get to it eventually, and then you can just leapfrog that. But then you can wait for me.
Mr. Johnson?
Yeah.
On number 6, how did you get 3 squares of x over 2 for the
You have to tell me which one is number 6. Is it front page, back page?
back page?
Okay,
X squared is X plus 1. The fourth from the negative. Yeah.
here,
Yeah.
this one. And this is number 6. Okay. Well, if I say here's the function, I am not going to do derivative yet. My problem is this guy is fine. He is in power rule format, a number times x to some power. This guy is not in product or power rule format. This is not a number times x to some power. So at the very least, you need to sidebar and say this is x to the first times x to the 1/2. And what do you do with exponents when you multiply things with the same base? Okay, so this is really like x to the 3/2. Now keep in mind, I haven't taken a derivative yet. I just did an exponent rule. But now that it looks right, now the power rule should be fine. Now I can bring the 3/2 down, lower the power by 1, bring the -1 down, lower the power by 1. And again, I know they're going to do some simplifying here. They're not going to say x to the 1/2 at the end. They're going to change that back to the square root of x. And this x to the -2, they're certainly going to bring to the denominator to make x to the +2. So I would be looking for this as a possibility. And that's there. It's in the bottom right. Yeah, so the main thing, so again, in theory, not exactly question for question, because everybody finds certain things more difficult than others. But in general, as you move through these questions, they should just be a tiny bit harder. The first couple questions were in power rule format, ready to go. But once you got to this one, which I think was question 6, you needed to do something to that first term to put it in power rule format. So, which is typically the case. If everything was always ready to go in the right power rule format, then we wouldn't need to spend more time practicing this. Okay, offer in with another question or two, maybe question 6, 7, 8, well we did 6, I'm sorry, 7, 8, 9.
Teachers, please pardon this interruption. At this time, we need the underclassmen who need a retake with last name that begins with the letter M to please come to the lower level of the PAC. So 9th, 10th, 11th graders with no Bulldog Blitz pictures. If your last name begins with the letter M, please come to the PAC. Thank you.
Yeah, John?
Could you do the second from the top on the left and the back page?
Second from the left and the back of the top page. This?
This way.
I don't know how I figured that out, but okay. What number is it?
It's 10.
Does anybody agree that's 10? Okay. Okay, so you're not going to like this, but for question 10, I'm going to do this two different ways. Just because I want to show you that you have options and you're encouraged to do this the way that makes the most sense to you. So when I glance at this, I see I've got a function 3x times a function x plus 5 squared. So one option, if you feel comfortable with the product rule, this is something times something. In theory, you can do this with the product rule. You can take the derivative of the first with the second left alone plus the first left alone times the derivative of the second. And now even this, you can still use power rule on this. You can still bring the power down and then lower the power by 1. So the derivative could be 3 times x plus 5 squared plus 6x times x plus 5. Now that probably doesn't look like any of the answers, but that's because you could FOIL this, you could distribute the 3, you could distribute the 6x, you could combine like terms. You know what I'm saying? So I did the calculus, and the calculus is correct. But just because you can do the product rule doesn't mean the product rule is what's easiest. 99% of the time, if you can make this look different with algebra or factoring or fractions or exponents or anything like that, you tend to want to do that before the calculus. So I will, bless you, square x plus 5. That would be x squared plus 10x plus 25. It's not just squaring the x and squaring the 5. You actually have to FOIL it out. Then I would distribute the 3x. And the nice thing about doing that is now that I have written it in a certain way, now the derivative is going to be much easier. Power rule 1, 2, 3 times. Whereas this method, again, product rule would give you the same thing, but you're going to have to distribute and combine a lot of like terms, and you're going to have more steps than somebody who just rewrote it and did the power rule. And again, that's what the challenge on this worksheet is going to be. I know you all understand bring the power down, lower the power by 1, but changing things to the right format is where the practice will help. Okay, was anybody else going to ask about number 10? Have something specific about it? Again, I have no issue if you prefer to do product rule. Just make sure that you end up with the right answer. Also, if you take the product rule route, if it seems overly complicated, you'll probably need to erase and restart. Okay, how about anything, questions 1 through 12 or 13 or 14? Okay. I'll give you some more time to go work then.
first person to go for that.
I don't think you can do that.
You don't like Jolly Ranchers?
They make my teeth hurt. I mean, if you just FOIL this becomes x squared minus 25. So I would just put x squared over x and then minus 25 over x. And do those two sets of the first one. Make those level with the apples. Okay, no, they're in advisory.
Sorry, I know some of these are kind of cold. They melt. Somehow they melt if I. You don't remember all the Jolly Ranchers I gave you last year? Huh?
That was you?
Oh wait, that wasn't your class.
2000.
You were in the bad class. Huh?
Did you do the top right one on the front page?
This one? Okay. What number do you think it is?
12.
12. Okay, what I would do for this question, again, I'm thinking unless it looks like it's ready to go for a power rule, I'm going to rewrite this some way. So one thing you could do is you could FOIL this numerator. It would end up with this, but plus 5x minus 5x is going to cancel out anyway. So you could also say the function is x squared minus 25 over x. And what I would do is just split this fraction apart. I would put x squared over x minus 25 over x. And then you can simplify this one to just be x. This one you can rewrite. You can make it, pull it up and make it x to the negative 1. And now that I have it written in this way, finally I would think about derivative. The derivative of x would be 1, and the derivative of minus 25x to the negative 1. You have to bring the power down, lower the power by 1, and then you're surely going to have to bring that down before you're done. So, in theory, you could do quotient rule there instead, but FOILing, combining like terms, simplifying fractions, and then power rule is probably easier steps overall. Okay. Is there a couple more I can help with? Okay. I'll do a few more minutes.
Yeah, because on the same light term. I'm gonna try them out a little bit.
You need to finish 21 and then turn 21 and 10 in at the same time.
Could you do the second one on the front page?
Second, front. This one? Okay, well, first off, you need to know that k is supposed to be a constant, some unknown number. So this part is actually pretty easy. It just looks complicated. Like, what would the derivative of 3x be? Okay, what about negative 7x? Okay, so what about square root of kx? Square root of k is just a number. None of these. Square root of k. If you've got a number times x, the derivative is just a number. A number times x, the derivative is just a number. Square root of k is just a number times x, so his derivative would be square root of k. Just a number times x, just like you always do up here, just less comfortable because we don't know what that number is. But this part, you probably want to rewrite the square root of x as x to the 1/2. That way you can bring the power down, lower the power by 1, and then you can see this is negative, so move it to the denominator. So 1 times k in the numerator, 2 times the square root of x in the denominator. Something like that. But k is just a generic constant. treat it like a constant. You just don't know how big he is. Is that enough? All right. Does anybody have another question or two ready? Okay. I'll start switching back to the agenda here because, again, I know some of you guys will need another 30 minutes or so for this circuit. Some of you probably will finish up in about 10 or 15 minutes. Just depends on how quickly you have caught on to all the power rule type of questions. So again, as you finish this, find it with number 10 in your binder and go ahead and turn them in as you're done. And then pick back up on the book
Teachers,
assignment.
please pardon this interruption. At this time, we need students' last name beginning with the letter N who need a retake to come to the lower level of the PAC. So 9th through 11th, if you did not get a picture taken during Bulldog Blitz, we need you to come down for your yearbook picture. If your last name begins with the letter N. Thank you.
Mr. Townsend,
Yes.
can you do the fifth one on the left column on the back? Where the answer is K over 2, the one that we just did, or not that we just did, but it was the answer to.
This one? So what I would say for this is either, you could either do quotient rule because you've got a function divided by a function, and if you really want to do power rule, which is what I would prefer to do, I would split this fraction up. So never split apart a denominator, but you can split apart a numerator. You can put 3x squared over 3x squared, as long as you put minus x over 3x squared and minus 2 over 3x squared. You guys are just used to going this direction. You're used to getting a common denominator and then pushing it all together as one big fraction. But a lot of times in derivatives you want to kind of split it apart, and then I would simplify these. 3x squared divided by 3x squared would just be 1. This x could cancel out this x. And I can move it up to the numerator. And this x squared I could move up to the numerator. And now it looks a lot like, not exactly like it, but a lot like question 6, I think. So now I'm going to start to think about derivative. Derivative of a constant is 0. Derivative of this guy, I could do power rule. Bring it down, makes it positive. Lower the power by 1. You okay with why this is x squared in the denominator? Okay. And could do power rule here. Bring the power down, that becomes positive 4/3. lower the power by 1, it becomes x to the negative 3. So I'll move it to the denominator to make it x to the positive 3. And then that should be it. Yeah, it's middle right front page. But this idea of taking a fraction and splitting up the numerator over the denominator, that's a very common trick to make it work out nicely. Split it up into 3 fractions instead of 1 big fraction. Simplify each of the 3 fractions, and then the only calculus is power rule 3 times, or power rule twice, and knowing the derivative of the constant is 0. Was there something more specific there? Is that okay? Yep.
The right to the bottom, second one to the bottom, the back page.
This one? Okay, so for this one, you could either do product rule. You've got something times something. The main thing is don't just do the derivative of this, then do the derivative of this, and then slap a multiplication symbol in between them. That's avoiding the power rule. But to do the power rule, you can just multiply these together. They already have the same base, and when you multiply things with the same base, what do you do with the exponents? One more time. Add them. So this is the same as this, and then if you add those two, you got to get a common denominator, but it becomes x to the 7/6. So that's still what y equals. So now the derivative of that, bring the power down and lower the power by 1. So it might be that, but more likely they're going to change this to the 6th root of x. That's what I would expect it to look like. So again, another question, not ready for power rule until you do some other math thing before that. In this case, multiplying things with the same base.
I took one home on accident and I didn't know it was the same one.
That's illegal.
I'm very sorry.
I have a question. Whatever. That is great. Let's put that out.
Okay, you could split that up. You could rewrite this. You could rewrite. I can't tell where you're going with this.
Well, I subtracted the exponents.
Okay, so you went from here to here.
Yep.
Okay, then you rewrote this one as x to the negative 1.
Then I dropped the power by -1. And I got -1 plus x.
Okay, but here, when you drop the power,
Yeah.
you bring the power down, which makes this would make it a negative x.
Oh.
And then you need to lower this by 1. So
One.
it's going to become negative x to
X.
the negative 2.
And then you drop the 2. Right.
Drop the x to the negative 2
Negative
to the
two.
denominator.
Yeah.
But then you also lost this somewhere in here. The derivative of x would be 1.
1. Oh, okay.
Oh, that's right. Did you do that? You're at the
You do this one.
Sure. Wait, let me see what you got down.
Okay. That. No, that. Sorry.
Okay. That looks good.
I
You just
couldn't
didn't
find
simplify it yet. So, I agree with everything you did to get to here. Okay. None of the answers look like that. But there is one that you haven't used that's similar.
Right.
And so what they did is instead of calling this 1, they called it x squared over x squared.
Oh, common denominator.
So that way you get a common denominator. And then they just put this one first and that one second.
Okay.
So
Thank
you just need the common denominator to finish.
Joe, you already done with the bookwork? Oh, no, not the whole thing.
Last page. 17. It's not. Oh, yeah.
Teachers, please pardon this interruption. At this time, we need students who need a retake, who are underclassmen, last names beginning with O and P, to make their way to the bottom part of the PAC, the stage area. So 9th, 10th, 11th grade, you didn't get a Bulldog Blitz picture, and your last name begins with O or P, please come to the PAC at this time. Thank you.
We're supposed to turn this in, right? Okay.
But what's assignment 10?
Oh, 10?
10 and 21. It's up there. 10 was from a while back. I just wanted to give you points for it.
I'm doing it right.
Thank you.
Did you get suspenders? Everything but that? It's actually the first time I've considered it. Really? Ever. So good. That's nice.
How long did it take you to finish the bookwork?
Well, I spent 1 or 2 hours on it last night, but I did 1 minute and a live.
Oh, that's not too bad.
Yeah, it wasn't terrible.
Where did you get this answer for that? For 19.
You actually use your Steam Deck, or you just kind of have it hanging?
Yeah, it's definitely.
Steam Deck.
Your little
Oh,
gadget.
Stream Deck. That's not a Steam Deck.
Stream, whatever.
Well, a Steam Deck is something else.
Steam Deck is an entirely different thing. I know, I'm aware.
Yeah, I use it.
Like,
That's how I record class every time.
oh, I thought you just have like an app on your tablet or something.
I just click this whole button.
Oh, that's pretty neat. How much was it?
It's like 100.
Okay, well, I'm not, for like 60 buttons, but.
Well, you can get smaller ones for cheaper, I think.
So you get. So it's 1
But unless you need something, I mean, you probably don't really need one. Say what?
Pretty convenient.
I would never use one at home. I like it because it makes it easy to pull up calculator or switch back to the worksheets or set timers, all that kind of stuff. That way I'm not alt-tabbing all class
Yeah.
being distracting. You know what I mean? Since I have different buttons. Like I have a calculator button, so if we need a calculator,
You just.
like I'm not going down here like switching around all the time. I just have buttons that make it.
You have a, like,
you have like an app that shortcuts it, or for what? Because I don't know how you make that button.
It's a keyboard shortcut.
Oh.
Like Windows, like I think it's like Windows 1 is your first item down here, Windows 2, Windows 3, Windows 4. I think that's the shortcut. Yeah, that's what it is. So whatever you have down on your start bar, 2, 3, 4, 5, 6. Like this is 6, so Windows 6 pulls it up. So these are tied to that. Yeah.
Ask for one question. I got stuck on this one up here. So I tried quotient rule first, and I think my arithmetic was wrong, but I couldn't find the issue, so I switched to trying to use power rule, and I got stuck.
Okay, so FOIL this together, what do you get?
You get x squared minus 25.
Okay, and all of that's over x. So let's put x squared over x. What would that reduce to?
Just x.
Okay, so write that down. And instead of saying 25 over x, what could you say? 25 times x to what power?
-1.
Okay, so you've got a minus 25x to the -1.
That's -1.
Okay, so now it's been rewritten. We've distributed, and we split apart our fraction, and we simplified both fractions. So now just do power rule here and power rule there, and this should get you your answer.
Also, I tried to skip it at one point just to go ahead, and I got this. I haven't tried to multiply that yet, just because.
Okay, what you're doing here, this is not legal. You don't get to just take the derivative of this, then take the derivative of this, and then slap a multiplication symbol. That goes against the whole product rule that we learned. If you have something times something, you can either do product rule, or you can combine this together. So in this case, when you multiply things with the same base, what do you do with the exponents?
You add.
Okay, so all of this is really the same as x to the 7/6.
Yeah.
And if you do that, then it's easy to do the power rule too.
Thank you.
Are you done with this?
Oh, yeah.
You stick with your, I just want to sit like that.
You don't need to say things like that.
Nope, it's for Gabby.
It's for her college. Well, like the shocking part of it, you know.
Exactly.
Girls, y'all are done with the bookwork too?
Mr. Johnson, could
Yes.
you do the third one in the left column on the back?
What happened to my question?
Your question.
Yeah. I asked if y'all were done with the bookwork. Okay, which one? I didn't hear which one you said.
The
2 pi x. This guy?
Yes.
What number is that?
Number 22.
22. Okay. Okay, so similar to what you probably did in other questions is I would split apart this fraction. So you can put x to the -2 over x to the -3, as long as you also put x to the -1 over x to the -3. So let's split apart your fraction. Now that that has been split apart, I'm going to simplify this. So if you divide things with the same base, what do you do with the exponents?
You move the -3 to -2 and it becomes 1.
Okay, that's fine. Or you can just say, if you're dividing things with the same base, you subtract the exponents. -2 minus a -3 does get you x to the first. So either way, you see that. So what do you think this is going to reduce to?
X to the second.
Okay, very good. -1 minus a -3. It's like -1 plus 3, which is 2, x squared. Okay, well that's still the function because we never did power rule. Now we can do power rule. The derivative of x is 1. The derivative of x squared would be 2x. Once again, it's not the calculus usually. Calculus is usually fine, but the algebra, getting it set up right, just takes lots of practice.
I have a question. Did you explain me how to do this one? It's on the worksheet, the worksheet.
I would distribute this x. So this would be x here and then a 4x there.
4x.
And then when you start talking about the derivative, now you need to be careful not to say equal, because the function might be equal to this, but it's not equal to the
To that,
derivative.
okay.
Yeah. You can put an arrow if you want, but not an equal sign.
Okay, I just do it like on the bottom. Just put like that.
That's fine, yeah. But I would distribute that x first up.
So it'd just be x minus 4x.
When you multiply a fraction by something, it only goes to the numerator.
Oh, nothing.
So the denominator stays the same.
But that x minus still stays in the. Okay.
Okay, so now you can start thinking about derivatives. The derivative of x would just be 1, but to take the derivative of this, you're going to have to use the product rule.
Okay.
Or I'm sorry, quotient rule.
Quotient rule?
Yeah, because it's divided.
So then after I use the quotient rule, I can just combine it with whatever, with 1.
Yeah, you're going to have 1 minus this big mess of stuff from the quotient rule, and I would just start looking at the answer to see how much you need to simplify it.
Okay.
Thank you. Thank you. Thank you.
Just throw it back.
Yep, throw them in there.
You turn both? Yes. Can I also go to the bathroom?
You'll have to wait for the pass to come back, but as soon as she's back with the pass, you can.
I think I messed up on the 6. I'll just see 6 real quick. I want to see. I think I messed up on it.
6.
It's it's real.
Oh, sorry. Was it
We're really gonna start with half of
this one?
and then moving on. It has to be turned in.
I just rewrote that with the exponent rules.
Oh, it's you wrote
Because
it.
if you multiply things with the same base, you just add the exponent. So then
Okay.
power rule, power rule.
All right, that's
When we get to the halfway point of class, then we're moving on to something else. This has-
Like samples.
Or maybe not. Yeah, I'll just do them. Maybe not.
You got calculus and physics on the same day?
No, not the same day, but actually in the same Monday.
Yeah, last year's group, I think they like circuits more than anything else. But I try to mix it up a little bit. I just like, it's satisfying when that last question has to answer the comes back.
Yeah. I don't think I'm gonna go for nuclear science.
And it's a way that you can kind of get feedback that you're doing it right without being told what the answers are, so.
Aw.
I see it right, but I don't really know. That's not yeah. So we did last week. That's oh wait, in school Fridays we did it. Wait.
Right? I was thinking of everything. Because I know someone in the fourth period was talking about how they did bulletin boards, and I was like,
Because we get to speak about these every Monday. And then every maybe
Are you guys able to understand the daily meme yet? My third period class yesterday couldn't figure out why it's the daily meme.
Is it supposed to be like,
No,
wait,
it's
this
supposed to be
is easier, or like,
Yeah,
wait,
so,
this is better?
yeah, he wants to use quotient rule, but it would be just a lot easier to rewrite it and do power rule. So you could do either, but you don't want to just automatically do quotient rule, because sometimes you're doing a lot of extra work. Okay, and again, just to be clear, how much more of the book assignments you need to do is up on the board. 10 questions in class is what I was asking you to aim for, and 5 more for homework. So I'm repeating this because you don't have to have it 100% complete by Thursday. If you have time to do it, it's not going to hurt you, but I will give you a little bit more time before I expect it to be done. But you should be about like 8 or 9 questions from being finished if you keep up with what I'm suggesting.
Oh, I just feel what it is. I don't know. Oh, no, I didn't do that, I just brought it up. Like, so like, I said let's put this in -1 and you know, I left it there. I didn't mess it. Just put it it's close, but not so close. Denominator is right, I don't know how to get the numerator to look like that.
Okay, so we've got about 10 minutes here, so I'm going to switch the screen, make sure you know what your homework is, if you had some. So most of you should have had 5 more questions from the book assignment, unless you worked ahead. But you might have a couple more than 5 if you didn't get 10 of those questions finished. So make sure you are aware of that so you're not falling behind. And you're obviously welcome to keep working on that. But also a reminder, don't keep the book handout. The book handout is mine. You have a digital copy of the textbook on Google Classroom. You can download it one time and have it all year. Secondly, there is a couple more resources around the classroom. So one thing is, by your table numbers, I added another little piece in here. Now this won't be here all year, but do you guys recognize what this is from? Okay, well it's not just the plain unit circle, it's something specific about the unit circle. What?
Is it the locations of like the tangent points on the unit circle?
Yeah, it's the tangent values at each point on the unit circle. So, again, you could always find those with sine divided by cosine, but there's really only 3 values, and they get repeated, well, I guess plus or minus. Plus or minus 3 values. Second resource, if you're interested, this is a poster that I've had, that I finally had laminated. So I'll be checking off the skills that we've done. This is from College Board, but it shows you from Unit 1, how much of it on the AP exam, the skills, and you can see we've already done those. Those are from limits. And then Unit 2, what we're currently in, you can see the things that they expect you to know and which ones we've talked about already and all that kind of stuff. So if you're interested in that, I put it up here for you to see. All these purple ones, though, those are for BC. So we don't have to do these 2 units, and we don't have to do any of these other ones on there. But if you're ever interested in what they expect you to know for the AP exam, that is there. Okay, and then finally, I think I know what puzzle you're on. You did the lock puzzle last time. Does that sound familiar?
Yeah.
That one? Okay. How about rectangular board puzzle? Okay. If you're interested, there is your puzzle for today. So, keep working on your math or work on the puzzle is fine. One or the other. But you got about 8 minutes, so it's time to go. Yeah. So this is like x to the 1/2. So if we bring it up, this is like, all of this is like x to the negative 1/2.
Yeah.
And then this is like x to the 1/2.
And then do you do the power rule after that?
Twice. So you can do the power rule to x to the negative 1/2 plus, and then do the power rule to that one too.
Okay. Yeah. I did the power rule once and then it looked weird, so I erased it.
He said that people average a 63 on that project, on the essay. Like we have the essay.
She never liked me, dude.
Like for the big one?
Not like me.
No, I think it's like a mock.
Those are like harder,
And he
easy.
said he grades it like the 18 exam. He hasn't even talked to anything. He's really in the book.
Yeah, I know. But then like also like the procedure, like what you're supposed to do, and then you'll write one, and then you'll What? I don't know. Like you write the essays and then you write this and do University of Arkansas. I can't remember. Yeah, that was like your final.
It's really cool. The way.
I know.
I will in that class before it's like every day and it's so embarrassing. It's like, hi, he didn't say anything.
And you're just like, whenever I wrote I wrote it and it took 4 hours. Oh yeah, but it's not really.
Yep. Has anybody got any suggestions on how to approach this?
You cut like a little bit off of the right side and then move it to the left, and then you cut off the bottom, move it to the top.
That sounds good, but how do you know that it's going to be in the center?
You measure the distance from the hole, and then you have to measure from the hole, from the edge of the board to the hole on the left side, and then you have to move that distance.
They were always hard.
You have to see that distance on the right side of it, and then cut it in half, and then cut that much off of the other side.
So you're saying cut off some of this right side?
Yeah.
I'm saying, how do you know how much?
whatever distance is between the left side of the board and the right, the left side of the board.
This distance?
Yes, and then you,
So you should cut this off, okay.
not yet, but then you, that distance on the right side of the hole, and then, wait.
How does this,
I lost my-
how to add this over here, get this in the middle?
Yeah, and then you cut the bottom off.
I think that if you cut off this much and put it over here, I don't think this is in the center
Yeah, it's
horizontal.
not. You have to like cut half of that distance on the right side, and then
You also just do that and cut the piece of that and have to put each piece.
I wasn't able to finish this.
Okay, just give it to me at the start of class next time. I won't think to ask you though. It'll be under bill work, but I won't think to ask, so you need to be looking for it.
I think you guys are on the right track. I don't know if it will work, because I didn't hear a complete thought.
it's hard to say.
I got you.
About the chip off and still hurt so bad.
I did post a solution to this on Google Classroom. If you want to see if you're right.
There's definitely a shorter way to do
I got to 21. Am I gonna get half credit?
Sorry?
I got to 20.
Just turn it in at the start of next class.
Okay, finish it.
But I'll have it listed under bill work, but I won't think to remind you.
Okay,
So,
yeah, thank you. Can't wait to go to the revenue office to get my driver's license ready today. No, my birthday left. Too much. Yeah. No, it's expired. A little while.
Good day.
I'm not gonna steal it this time, Mr. Townsend.
Thank you.
Mr. Towns, when's the book assignment due, like as a whole?
I'm going to give you a little more time on Thursday, so I'll be picking it up on Friday.
Bye, Mr. Kelly.